Now, what's really cool about having a nitrile and knowing that a nitrile can be converted to either an amide or to a carboxylic acid is we can use this, we can exploit this in synthesis because cyanide is, there's a little lone pair here too, cyanide is a good nucleophile. So there are strategies to get the nitrile functional group into a carbon chain. So let's see an example where that might come in handy. So we have a 3-carbon chain here, and we want to convert it to this new compound. We still see our 3-carbon chain, but we see that there's this new carbon that's added on, and we need to synthesize that. Okay, now let's think about a retrosynthesis. What starting materials do I need? There's actually a few different approaches we can have for this. One of them would be the nitrile that we just saw. So one approach is we just saw that where you now have a carboxylic acid that could have come from a nitrile. In other words, if I had this nitrile, I could do a hydrolysis to get this carboxylic acid product. Okay, so that would be a good strategy. Now we have to do this disconnection and ask ourselves, if we wanted these 2 carbons to come together and react, how could we do that? One of them must have been a nucleophile, one of them must have been an electrophile. Well, what we're remembering is that cyanide is a good nucleophile, so this certainly was my nucleophile, but that means this carbon was my electrophile. Somehow I have to make that carbon electrophilic. Well, I'm starting with isopropyl chloride. I'm starting with a leaving group in that position. It's already electrophilic. So I think I've done enough planning here to think about my synthesis so I can go ahead and do my transformation. I think my first step is to treat this alkyl halide with sodium cyanide to do an SN2 mechanism. That will replace the leaving group with the cyano group. And once I have the cyano group, now I can convert it to the carboxylic acid by hydrolysis. I want to trade those CN bonds for CO bonds. That's hydrolysis, H3O+. Remember, some heat is required because we want it to not stop at the amide. We want it to go all the way to the carboxylic acid. That's a kind of a forcing reaction. Okay, so nitriles are very handy this way as a way to synthesize carboxylic acids. One last look at this problem. There's another strategy that we can think of. We've actually seen this as another way to make carboxylic acids would be exactly this disconnection as well. What if we asked about these 2 carbons right away and think about, instead of doing a functional group interconversion right here back to a nitrile, what if we did a disconnection right away and asked about these 2 carbons? Which one could have been a good nucleophile? Which one was an electrophile? What reaction have we seen that comes together and forms a carboxylic acid? How about if this carbon was my electrophile? What would that electrophile look like? A carbon with 2 oxygens. We could have carbon dioxide as an electrophile. What nucleophile would react with carbon dioxide to give this target molecule then? How about if I had a Grignard as my nucleophile, then that would react with CO2 and it would give this target molecule exactly. Okay, so that's another approach we can take. Let's see how that would look. Well, we're starting with a chloride. I know with the Grignard we usually think magnesium bromide, but remember a Grignard can be any halide, so we don't have to change that. We could just throw in our magnesium right away and make the magnesium chloride Grignard. Now I have a good nucleophile. What did I want to do with that nucleophile? I wanted to react with carbon dioxide. So remember, that's a 2-step process. First, I can add in carbon dioxide. And second, I could do an H3O+ workup to protonate. And so this would give another strategy. So in this lesson, we've been introduced to carboxylic acids, looked at their acidity and their other physical properties. And then we've also seen different ways to synthesize carboxylic acids. We looked at oxidation reactions. We looked at Grignard reactions to form them. And then we looked at carboxylic acid derivative hydrolysis as another way to form carboxylic acids. So we studied the mechanism of that hydrolysis reaction. And in the next lesson, we're going to look again at these carboxylic acid derivatives and think about what reactions do they undergo and how can we synthesize each of those functional groups. So I look forward to seeing you then. Thanks for visiting Educator.com.